summit, and we're happy that you could stick around for our session. My name is Janelle Kerrisk, and I'm a director at Helix Legal, and this is my colleague Michael. We both head up law firms that specialise in the construction industry, and we've really enjoyed the last 2 days and being along for the journey to see the discussions that have been occurring. And you are in for a treat in the final session of this afternoon. We had an introductory session with these lovely panellists, and Mike and I had lots of conversations afterwards, and they totally blew our minds. So I'm going to hand over to Mike, who's going to kick things off, and then hopefully we can get you engaged in some conversation, get excited for the afternoon, and we hope that you enjoy the session.
Thanks, Janelle. I think I've got the microphone hooked up to me. We're used to handing it across. But look, Janelle and I, when we were chatting about it earlier, we've gone with the approach where it's hard to finish the day listening to lawyers. The most interesting people are all here. So I guess what we wanted to start with, so Janelle's introduced us. We're lawyers. We specialise in construction. We've got a really wonderful mix from UTS, and even today when we were sitting down working out what we're going to talk about, I think we've already shifted ideas in the last hour as we've talked with Fraser, Peter and Sarah. So I guess what we were going to open with is let them, I can't really do justice to all the interesting things they're doing. We're going to throw to them to introduce themselves a little bit, and also to tell us about one thing that they find really exciting at the moment. So Fraser, I think you're first.
I'm Fraser, pleased to meet you. I'm the Director of the Plants and Environmental Quality Research Group at UTS. What we specialise in is green infrastructure. We started off looking at pot plants removing air pollutants, and that's research has grown subsequently to all of the ways in which you can fit planted materials into the built environment, mainly for improvement of air quality, but now we're looking at noise reduction, thermal properties and so on, and we're finding that the natural properties of the materials we're using are higher performance than a lot of the existing materials used in the construction industry. What was the next question? What do I find exciting?
One thing. We'll start with one thing and we'll work into the others.
And I'm going to ruin everything else I was going to say. One of the questions that was posed originally was how can the construction industry learn from other industries? And I reflected on that for some time. And I'd like to rephrase that whole idea and what other industries can learn from the construction industry. Our experience has been that the construction industry has been absolutely upfront, forward-looking and excited about progress. They've jumped on the idea of having green walls on buildings for functional purposes, not just for decorations. So I've found it's a breath of fresh air moving from science into working with the construction industry. That's been fantastic. We're overwhelmed with commercial partner opportunities with the construction industry. They've been more excited about moving forward and more excited about decarbonisation and sustainability than anyone I've experienced before. Enough?
What about you, Peter? What are you excited about? What's floating your boat right now?
So what I'm most excited about is opportunities for the bioeconomy. And what we've got to find is ways by which into the future of construction, we can link construction up with other people that have got service problems, such as waste. We can take CO2 out of the atmosphere and then stick that carbon into the buildings. If we can do that, the planet has a future. And I think construction is an absolutely key part of the sustainable future. And we've got to work out ways where we can get our carbon into your buildings, because the carbon trading market and sticking carbon in places that we don't use is not going to work. Whereas construction, you build buildings that are around for quite a long time. They're not 100 years like we need to store the carbon, but if we can store the carbon in your buildings, whether it's in wall panellings, not in structural concrete, but in wall panellings, polymers, a whole range of different components, that's going to be key to society. And that's what I'm really excited to find out, whether or not the construction industry is ready for us.
And what's your background, Peter? What's your connection with the construction industry? Tell us about that.
So my background, I'm a biochemist. I understand all about the photosynthesis that happens in tiny little plants. what's that got to do with construction industry? It's Sarah. Sarah brought me along on the journey. So she and I have been working for 5, 6, 7 years. As a marine biologist on the last day of a conference on a Friday evening, it's a tough call to try and get construction people excited. But yeah, I'm a biochemist. So I like to be able to translate and swap boundaries. So I don't want to talk about the details of photosynthesis to you guys, but I want to be able to talk in a language that I can give you a compelling argument why you want the carbon from the atmosphere into your buildings. And I can translate that using the photosynthesis of algae.
And Sarah?
Yep, so I'm Sarah Wilkinson, and my background is chartered building surveyor, and I teach sustainable construction and construction to property students and planners mostly. So I got an email from Peter, as he says, about 6 years ago. Can you come to a meeting? I looked at my diary. Yes, I replied. And then I checked Peter out and I thought, I think he's made a mistake. Why would a marine biologist want to see me? And I went to the meeting and Peter showed me this BIQ building that Arup had built in Hamburg, which used algae facade panels to grow biomass on the building, which could be converted into biofuel. And that was a source of renewable energy. And he looked at me and he said, would that work here? And I said, I don't know. I've never seen anything like that. And that's what really excites me, is working with people like Peter and Fraser, who are totally not in the built environment disciplines. They come with totally different ideas that make you reset your thinking. And Peter is absolutely right. We've got to decarbonise the built environment. And we're learning that there are ways of doing that. And we need to even go one more and become carbon positive. So we're actually giving back and making the environment better. And time is running out.
And do you think collaboration is a big part of that? So there's been an email and a knock on a door and a conversation that's obviously led down a long path. Do you think that that's the key for the future of construction, is those collaboration partnerships?
Absolutely. And what we've been able to do is, with fairly modest sort of grants and opportunities, is do the proof of concept. And again, it's been in that safe to fail space that was talked about yesterday, where you're not doing things on a huge scale and you're couching everything in, well, this has never been done before, so we'll see how it goes, and be prepared to create the dinosaur. And I don't mind when someone comes along and looks at something I've done and says, Sarah, you idiot, why didn't you do this? Why didn't you use that glazing or those seals or that material? And that's really great. And I find that Peter and Fraser are very much in that mindset as well. And together we're able to come up with some really innovative ideas.
I think one of the things that is driving me to find these collaborative opportunities, so we work in the food industry, so I'm looking for parts of industry that are massive in scale that can take carbon. Construction is absolutely one of those industries, and there's no way for me to... How would I, as a marine biologist, get to present to a bunch of construction experts? So the collaboration to work with the different parts of in a university academic environment, we can do that, but it's to get to these industries that have got massive impact. That's what I'm interested, that's what I'm looking for. Who can take millions of tons of carbon and do something with it instead of sticking it at the bottom of the ocean? And that's what the planet's really got to make these decisions about. So industries can get on board quickly and see a market, and this is what we're talking about, the green jobs. How can we make a profit out of a problem that we've got and get the industry going quickly? So is there opportunities for this to happen really quickly to help the planet, but also drive new sustainable industries? And this is the conversation that has to happen across boundaries.
Yeah, absolutely. Like Peter said, and Sarah said, the time's running out and we can't continue down our individual rabbit holes in science. We have to start looking for new opportunities, and one of the things that's it's been really clear from collaborating with different people in a whole lot of range of fields, is that every time you talk outside your field, all you hear is opportunities. There's more opportunities, and they're opportunities that we need, and we need to get on with fixing the problems.
Yeah. And I mean, we're working with bioengineers, and again, I mean, when I graduated, there was no such thing as a bioengineer. And now there are, and I mean, the hempcrete project is going to be really interesting. We're going to be testing hempcrete wall panels for performance over a 3-year period, and we'll have miniaturized structures set up at the tech lab at Botany, and anyone is very welcome once we've got them set up to come and have a look. I'm sure we'll be doing some tours and what have you. Fraser and I are going to be putting green walls on the hempcrete panels to test the performance there, so we'll actually have some empirical data so that when people come to design and construct them, they've actually got some idea of what the performance, what the maintenance requirements are going to be, the pros and the cons, and et cetera, et cetera.
So hopefully we'll overcome some of the barriers to which I dare say will arise, because we're combining two out there technologies in the one space. So that's our job.
Yeah.
Overcome the barriers.
That must be really exciting, being able to test that kind of technology and to be immediately engaging with industry when you're doing so.
Absolutely, and we love working with industry partners. We've been very fortunate with the green walls to have a lot of input from Junglefy, who did the Central Park building, and we really welcome engagement with people that are out there, because it's better for us, because if we know the environments that you work in, the barriers that you face and the problems that you have to overcome, then we can shift our research focus so that it's going to help address some of those issues. So hopefully the work we come up with has got much more application.
Along that line, can you tell us how the wall bots came about? Because I believe there was a sense of trying to overcome barriers in that idea formulating. Can you tell us the background behind that?
So with the wallbot, the green walls, when you look at the benefits of green walls, you get better air quality, habitat for biodiversity, pollutants get absorbed, it looks good, you've got biophilia. On a city scale or precinct scale with green infrastructure, you can attenuate the urban heat island effect. So lots of pros for it, but it wasn't being taken up. And one of the barriers was OH&S issues, people sort of in window cleaning cradles, working at heights, and maintenance costs. And I saw a video of a farm bot, which is a bot that goes horizontally and it weeds, seeds, waters and maintains. And I thought, well, if you can go that way, you've got to be able to go that way. So I put in a grant application, got the grant, and then thought, I need to find someone that knows about bots and robotics. So when I made friends with Mark Carmichael, who's a mechatronics engineer, I had never heard of mechatronics engineering until that point. And we were able to prototype a really small budget. We had 20K, so we've miniaturized it down. We've got proof of concept with Warbot. We've got a 2-minute video that if anyone's interested, I'll send you the link. And that's got sensors in it. We've got the movement sorted out. We've got a control panel. And we've got, they can take images so we can look at plant health and things like that. We've got sensors that can detect oxygen and pollutants and those sorts of things. And the next iteration, Warbot 2, which we've just secured some funding for, is to get some functionality, which for me is a pair of scissors. But I'm sure it will be a lot more sophisticated than that. And to embed the control panel into a BMS, so you get a smart green wall. So, and then I've also had other fantasies about the facade bot as a building surveyor, sort of dealing with building defects and adaptation. I know that we're probably going to have a lot of defects in construction over the next decade or two because we've had such rapid construction of high density buildings. And possibly the wall bot could morph into, I thought initially of a facade inspection bot, but then I thought that was a fib. And then I thought if it was a facade assessment bot, it would be fab. So again, taking out some of the OH&S issues of people going up and down high buildings in window cleaning cradles, which I have done, you know, looking for cracks and signs of movement and, you know, missing fixings and what have you. You could have a bot to do that.
The opportunity is, with the bot being there, you can do it so much better.
Oh,
I mean,
yeah.
someone going up and down a wall, you know the volume of human error that goes alongside that. Having the improvement of buildings that, you know, that comes along with these sustainability and environmental elements is just phenomenal.
Absolutely, and actually having been here for the last 2 days, today I had a sort of bit of a ka-ching moment, and I thought, well, actually, if I put a paintbrush on the wall bot, it could become a facade maintenance bot, so an FMB. So I've got that one as well now.
Janelle, we've just got a question from the floor. We might as well take them as and when they're...
Yeah, please. Yeah.
Very exciting discussion, so I thought I'd interrupt with a question rather than wait for question time. So if you look at construction, the main areas of carbon producing aspects of construction, I imagine, the top 5 would include concrete and steel use, etc. So what are the top 5 problem areas in construction, and what are the top 5 opportunities that could replace? The only one I can think of is CLT, cross-laminated timber, that could turn a building into a carbon sink. But what are some of the others that are coming up that I haven't heard about yet? I'd love to know the top 5 things you can see between now and 2030.
Well, that's a good question. Go on, Peter.
I was going to go with wall panels. Wall panels, I think we're already having lots of questions about it. So I'm having to learn about flammability. So we're making a whole range of bioplastics out of seaweed and out of microalgae. So we take the carbon out of the atmosphere, use sewage as fertilizer, and we're making plastics. So imagine the wall panelings that go across these panels here. We put the right acoustics into it. We have the right flammability. I'm learning what has to go into wall panelings, but these are not structural things, but these are a fantastic sink for carbon-based materials. That's one of the plastic angles that I'm seeing in construction. You rattled off the main sources of carbon. They're easy to capture. We've got technology ready for clinkers, for doing all of the cement production. It's about the cost. So whether or not it's trapping the CO2 from steel construction, it comes down to the cost. And I think the challenge for the Australian industries, and I'm really excited that there's a lot of awareness, is the green tariffs coming in Europe. So it may not affect us in our construction industry here, but any of our products that we ship for the construction industry to Europe that do not have carbon credentials, we're going to be suffering a very large fiscal challenge. So I think our exporters of construction components are taking notice of this, and they're going to be looking for ways that our raw materials can be decarbonised and we can actually put those raw materials back into their products. So anything with plastic, we can replace right now.
Anything else?
There is biocements out there. There's biocements. There's bioplasters. There's fillers going into non-structural cement, so we can reduce the amount of carbon stored in the fossil-based carbon stored in the cement as opposed to a renewable source of carbon. But I think I'm very, very concerned about getting engaged with anything structural because I don't want bio-based products to be held up where lawyers are going to be taking me to court for a patent that I may have with a cement replacement that doesn't have the structural integrity. So that I think is a challenge too far for me at the moment. But I think the urgency that we've got to start attacking these problems, you know, we should be working on it. I have molecular engineers working at UTS on genetically modified organisms. I believe that society will be asking science for GMOs in a very short period of time to solve problems. So they're culturally not appropriate yet, but give us 5 years when the emergency becomes greater, that need and that capacity will be ready. And maybe we will have something structurally capable of replacing it.
On a serious note, is the risk part of the barrier to the introduction or the adoption of some of these things within the construction industry? We have had a discussion prior to this talking about the role that lawyers play in stifling innovation by putting the hogwash on any kind of activity that might involve some risk. But the lawyers are trying to be forward-thinking in that department as well, and you get the right lawyer and you'll be able to work through those things. But is that one of the main barriers around identifying and managing risk with trying new things?
Yeah, I think always, I call it the shock of the new, which whenever something new comes along that you're not familiar with, you're naturally risk averse. You're thinking, what is this? How does it work? Should I be doing this? And it's much easier to do the same old, is, you know, when you get a new job come in, you look at your previous specification, that worked, it worked the time before, let's do that again. It's easy. It's much harder to invest the time in researching something that's new, that hasn't been tested on a, perhaps here in Australia, it might have been tested in another country, but it's a different climate, etc., etc. So, yes, there is risk to be managed, but I think at the same time, I think the risk of inaction and not doing anything is getting greater every day. So we have to do things differently, that's for sure.
I really liked your comments at the start, Fraser, about what other industries have got to learn from construction. I wanted to take you back to that because we were having a brief chat just ahead of this session. And you think there's a lot for other industries to learn from what construction's doing and achieving at the moment?
In my limited experience, I guess construction and transport would be our other field. And transport have been a lot more reactionary and a lot slower to get on board with the technologies and a lot more focused on return on investment. I think construction industry has been willing to take gambles with ROI, whereas transport has been much less so. I mean, they need an explicit, calculated, fully costed return on investment to go ahead with some of the large-scale projects, keeping in mind the projects that we generally work on are quite large. They're multi-million-dollar, very large-scale urban greening projects, whereas the construction industry have been ready to go with that. They've been, I don't know if it's the resources in that industry that's made them more willing, or the fear of the future, like we're all discussing here. Have they noticed that these changes are coming and they want to get ahead of things? But willing to take those risks, I think, has been the main thing. And of course, it's our job to mitigate those risks. As researchers, we can't be promoting things that provide risks. It's our responsibility to provide good quality and appropriate outcomes for the industry. And I think the construction industry has been very easy to deal with and getting on board with what we've done. We've provided them the evidence, they've checked our evidence and they've gone ahead with it. This has been fantastic.
I mean, going back to the algae, so when I first met Peter, my experience of algae, slime, had been, you know, when I came
Sounds
across
so
it.
sexy when you say that.
Yeah, well, I do say it's time for slime now. But previously it had been a building defect, a slip hazard, probably smell, and it could be a health hazard as well. So I had quite a negative sort of perception of algae, and I met Peter, who thinks algae is the best organism on the planet. You know, and so I listened to him, and he's actually the expert. You know, as I say, my knowledge of it is peripheral, minimal. And in listening to Peter and learning from Peter and his colleagues, you know, there is opportunity, and not only is it a good source potentially of biofuel, but it's also good at bioremediation of water.
No, absolutely. Yeah.
So-
So wastewater contaminants, all challenges with. Just imagine taking nutrients and chemicals out of places and converting them into products. So that's quite easy.
Yeah, and you've got young Henrys to put it in their beer, haven't you?
We do. We work with young Henrys. So we capture their carbon. So we capture their carbon and use their carbon. But that's the same as you can do with any. So one of the challenges in the construction industry, I would love to work with CHT systems, genbackers. So there's genbackers all over Sydney, and they are meant to be sustainable. They're meant to be green engines, green gas engines, but they're still putting out 20% CO2. I want to be putting carbon capture units in those and making biofuels, making plastics in the city and making genbackers actually carbon neutral. So yeah, we can use carbon sources, whether or not it's from brewery. Brewery's a very trendy place to capture carbon, I must admit. And having events at Young Henry's is great, and I think I'll be down there for Science Week again. So yeah, so Young Henry's was a fantastic place to start. But the thing that I keep coming back to is scale, and you guys are scale. So you guys have got the opportunity to make a difference in what you do with your carbon, or whether or not you take new sources of carbon into your construction industry. That's the challenge.
And what's the big ticket benefits? If we're talking big picture, future of construction industry, what are the big ticket benefits to the construction industry taking up this opportunity?
Society's acceptance of wanting you to provide the products that they're desperately after. Consumers, and look, I can't speak for consumers of wall panels, but I expect that they're going to be asking what is the fossil component of that wall panelling. And the quicker we can start replacing fossil components with renewable components, society is going to be paying a premium. So every other product, whether it's plastics for consumers, whether it's paints, polymers, food components, we're working on about a 10% premium for being able to tell a consumer that their product is sustainable. So,
Fraser, I can see you nodding your head there. Did you have something to add there?
Yes, I think that covers it quite well. I think that's a complex issue about where we're going forward. But I think the societal benefits, both from society and of course also from legislation, are coming. We know they're coming. So
I think having seen some of the amazing sort of digital technologies and platforms that from yesterday and today, it's inevitable at some point there will be a tool that quantifies carbon in buildings and construction. And then once that comes in, then you can compare alternatives. So perhaps when you're tendering for projects, clients are going to be looking at the carbon content of your proposal. And if another tenderer has got a lower carbon offering, they may have a higher price, but that may actually be a better choice for them.
I think that's an exciting proposition.
Yeah.
And we did talk about it a bit when we initially met, that concept, and you touched on it a little bit yesterday with your sustainability panel. You know, if procurement starts to look at things very differently, we end up with a very different product a lot quicker.
Yeah, yeah. And I think, as I say, again, listening to some of the innovations in the technologies, if we can start to integrate some of those in the scientific experiments that we're doing, that means when they're getting near to be tested in the market, they can plug into some of the systems that you've already got operating and set up. And that seems like a great opportunity, I think.
I think procurement is one of the key ways going forward, because that has a whole raft of components that go into the building, and there's a whole range of topics that can be sustainably sourced. And we've spoken to a number of different procurement companies, both government and private, and this is the way to fast track it, because that gives the guarantee to the manufacturers that they know they're going to have a solid supply of sustainable raw material going into those products. So procurement, I think, is the key to the future. And whether or not government gets on board and puts a premium on some of its procurement. I think that will help some of these evolving technologies to be bootstrapped and to give security to the manufacturers that take on this technology.
Fraser, if you were to jump into your DeLorean and travel 20 years into the future and to go onto a construction site, what's the number one thing that you would love to see happening?
I'd like to see no air conditioning in buildings. I'd like to see buildings where the indoor environmental quality is being managed so that it's being provided to the occupants at a quality that's going to stop this wave of building-related illness that's coming our way. I'd like to see buildings naturally ventilated and with pollution removal done by other organisms apart from machines. So decarbonisation obviously goes beyond the construction itself. It's the way the buildings are used as well. Of course, I'm optimistically assuming that the construction itself is going to be decarbonised to a large degree, which I think it will. I'm feeling optimistic about that. Having got into the field, there's so many opportunities whereby it can happen, so I think it will happen. But it's got to be a holistic approach. The building first, then the way the buildings run, providing that environment for the occupants that leads to healthy, productive lifestyles. How about buildings that last 100 years? How about that? Higher value buildings. All of the alternative technologies are expensive. They're all expensive. They're not going to become cheaper than concrete. Making buildings last longer would mean that that value lasts longer and goes forward further, as opposed to being something that this building's only going to last 15 years, why would we spend 15% more on its construction? Rant over.
What about the rest of the panel? Any trips in the DeLorean? What would you like to see?
Yeah.
You ride bicycles.
Yes, that's right. Yeah, I suppose I would like to see buildings that are carbon positive, so they're a positive impact on the environment. They integrate natural materials such as plants and microalgae, and that we've moved away from more of a chemical-based construction, I guess.
I'll take the dream of us having an alga that can be incorporated into concrete, and I'm going to have a 3D printing automatic robot that blends carbon neutral product with other products. So we've got stable buildings that are 3D printed, but then the orientation, the geometry of these constructions have considered sharing their waste. So I would like the buildings to be constructed in a way that waste streams can be cheaply integrated into the bioeconomy, so that we're not having massive sewage distribution schemes, we're not having waste distribution, it's all circular.
Yeah.
And that, I think, needs some really forward-thinking planning. So it's beyond construction, it's planning, but it's part of your industry.
That's not going to work in a 15-year lifespan building. You're going to need the longer, older buildings to be able to manage systems like that.
Yes.
So yeah, that's good.
It can be done.
Do we have any questions from the audience?
Hi, Daniel from DB Vircon. I'm just curious with the algae. I'm just going to ask a dumb question. Would they need water and oxygen to live in the walls? And the second question, have you seen any digital interfaces that give you live access to, say, carbon credentials for design or construction or operations that are worthy of looking at?
The second question I don't understand. The first question I can answer. So let me start with the first one. I'm describing situations where we're capturing the carbon in live algae that needs CO2. It makes oxygen, so it takes CO2 in and it needs nutrients, but then we take the carbon, the products out of it. So we take the calcium carbonates, we take the polymers, we make products with it. So I'm not thinking about living algae in the walls. I've captured the carbon and then I've extracted the products out of it. So that's the answer to the first question, but the second one, I'm sorry, I didn't understand.
Yeah. With the Arup BIQ building, where they grow the biomass in facade panels, they inject carbon into the panels, and it sort of bubbles up, and then, as Peter says, it gives off oxygen, and you have a growing cycle of about 3 or 4 weeks, and the biomass gradually gets, more and more.
Dense.
That's the word I was looking for, dense. Then they drain it off, and you've got this sort of green, gloopy stuff. And then that is biomass, and that can get converted to biofuel. So it's all very technical with me. And they tested one type of algae, and I think there's something like 400,000 or something.
Different species.
Different
So
species.
Immense diversity.
Yeah. And so different ones might be able to produce more biomass, et cetera, et cetera. At the moment, the conversion compared to the other renewables like solar, wind, et cetera, per dollar spent per amount of watt of energy produced is not good, but we're at the start of the process. And one of the things I think might be possible is to have a small installation on a building sort of showing that this building has a different source of energy, but have an industrial scale generation sort of outside of the building in the country somewhere where you don't have to pay for expensive sort of facade panels that you did in the BIQ building.
Yep.
That might be the way to do it. So you've got off-site generation, but an on-site installation.
And the BOQ building also took the human waste from the building, so there's 16 apartments.
That's right.
And
yeah.
they took their waste, so there was no grey water leaving. It was all being processed, so it was circular.
Very good. Another bird from EY again. Another question, if I may. On a 40-degree day, or a 5-degree for that matter,
Yep.
how do you keep a building operative or acceptable without reverse cycle air conditioning? If that's your dream, I'd love to know how you can do that. And then the second question, rather than a building lasting 100 years, I imagine actually we're going to reskin our buildings every 10 years, simply because the technology advances. I imagine in 10 years' time, it's worth putting translucent solar panels on the facade of a building and make them energy generative and storing. And then every 10 years, you need to replace them because the efficiency's doubled. Yeah. But maybe that's not the case, but interested in your
That's why we come to these things, because to get those great ideas, that is a good idea right there. Yeah. Working with the hempcrete, I mean, hempcrete's going to be the next 10 years. What's going to come after that?
Yeah. Well, I mean, we don't know really what the durability would be, and we don't know whether putting the green walls on the front of it is going to protect the hempcrete.
Maybe we'll find something even better going forward. That's what we do. The question about the temperature modulation, come back to me in 3 years. We've put in the grant. We know we can do it. We know we can with the systems that we're researching, we have temperature and humidity modulation potential. It's related to the scale of the green wall, so it's a size thing. Can we do 5 degrees and 40 degrees? I don't know yet. We know we can do, we're very confident we can do 32 and 16, 5 and 40, results pending.
I actually wouldn't be surprised if we do retrofitting of some buildings with shading devices to try and keep the direct heat off the facade. I mean, it's obviously expensive to replace facades, and so you've got the expense thing to consider as well.
Fabulous. Thank you very much for all of your questions, and thank you to our panel. I hope that you've enjoyed the last session this afternoon, and I'm going to hand the microphone back.